Hello everyone, this is Grade 6, Module 2, Lesson 19 problem set. For number 1 it says, use Euclid's algorithm to find the greatest common factor of the following pairs of numbers. So let's take a look at A, and we have 12 and 78. We want to find the GCF, or the greatest common factor, meaning the greatest factor that both of them share. With this, we're doing the Euclid's method, meaning we have to take these two numbers, 12 and 78, and I'm going to divide them. And for the first one, it's going to go in 6 times, and that's going to be 72. So that'll get me 6. Now what I do is I take this remainder, and that turns into my divisor. So 6 goes there, and I take my old divisor, and that goes into the dividend. And I'm going to do this until I get 0 as a remainder. And that's what I'm going to get right here. So now my greatest common factor is the divisor that gets me to 0. So the GCF here is 6. Because I take this 6 as my remainder and I use it here. But since I got 0, it goes in evenly. That's my GCF. If I got a number here like 3, I would have to bring it over and do it again. So let's take a look at B now, and we'll do this one up above. So we have 18 as my divisor, 176 as my dividend. And this one's going to go in 9 times. And I know 18 times 9 is 162. And I'll get 14. So now that's a remainder. That comes over here, and 14 is now my divisor. 18 is going to be my dividend. So 14 goes into 18 one time. I'm left with 4. So again, I got to bring it over. So 4 here. My old divisor is 14. That goes in 3 times. That gets me 12. I'm left with 2, so I got to do one more. 2 on the outside, 4 on the inside, and that goes in 2 times. And now that I have 0, that's my greatest common factor, the divisor. So that's going to be 2. Interesting way of doing GCF, or greatest common factor. All right, 2 says, Juanita and Samuel are planning a pizza party. They order a rectangular sheet pizza that measures 21 inches by 36 inches. So I gotta draw that. 21 by 36. They tell the pizza maker not to cut it because they want to cut it themselves. All pieces of the pizza must be square with none left over. What is the side length of the largest square pizzas into which Juanita and Samuel can cut the pizza? So the largest square, meaning what do they share? We're going to do greatest common factor for this. And for this one, I'm going to use, normally make a little box for this one. Now, it's going to look different until I get it finished. So work with me a little bit. I don't want to close my box because I want to make sure I can fit everything in. So I'm going to do the factors of 21. And I know I have 1 and 21. 2 doesn't go into it, but 3 and 7 do. And that's it. Nothing else can go into 21. So now I can close this box off. So it's just like the box we made earlier today, but I'm leaving it open because I'm writing kind of big. 36 is 1 and 36. 2 and 18. 3 and 12. And this is why I left these open so I could extend them. 4 and 9. 5 can't go into it, but 6 can. Be 6 and 6. And that's it. So now I have to look through these and see what's the greatest one that they share. The greatest number that is in both this side and this side. And I see they share 1, but they also share 3. So 1 was shared, but 3 is the greatest common factor. So what is it? We're up top here. What is the side length of the largest square pizzas? That's going to be a 3-inch by 3-inch. So that's the side length of it, 3 inches. And I'll cross it off because I'm talking just one side length, 3 inches. That's the largest. Now it says how many pizzas of this size can be cut. So when we look at pieces, we're looking here at our diagram for 2. And now I can break, if I cut 21 into 3-inch pieces, I should have 7. So I'm going to do that. 1, 2, 3. So there's 7 on the side. And then for 36, I got to cut it by 3s, and I know that I'm going to make 12, because that's where I got the 7 from for 21. So if I cut, how many different 3-inch pieces can I make? I can make 12 going this way, so I'm going to do that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I could count all of those, but I know that I have 7 on this side and 12 on this side. All I have to do is multiply to get 84. That's how many pieces of this size can be cut. So that's 2. Let's take a look at 3 now. So for 3 it says, Shelley and Mikkel are making a quilt. They have a piece of fabric that measures 48 inches by 168 inches. A says, all pieces of fabric must be square with none left over. What is the side length of the largest square pieces into which Shelley and Mikkel can cut the fabric? So for 3, I'm just going to draw a diagram just so I get an idea of what it is. And this looks like 48 inches. This will be 168 inches. And now it's asking for the largest, what is the side length of the largest square piece? Meaning, again, I have to find my common factors of this. The greatest common factor, because the largest means greatest. So what I'm going to do for this one is I'm going to use this to show prime factorization, which means I'm trying to get to all prime numbers. So I know I can pick any 2 factors that make 48 other than 1. So I'm going to do 6 and 8, and then I'm going to break these down to 2 and 3, and those are my prime numbers. 8 can be 4 and 2, and then 2 and 2. So now I got to do the exact same thing with 168. And I know that 8 can go into it, and it's going to be 21 times. And then I can break this into 2 and 4, 2 and 2, and this one will be 7 and 3. So now I can just list my numbers, my prime numbers. And I'll use a Venn diagram to show it, because that's what we did in one of the lessons here. And I see that they share a 2. They share another 2. Share a third 2. Looks like they share a 3 as well. And that's it. And what's left for 48 is a 2. And remember, we're only looking at the prime numbers. And what's left for 168 is 7. So when I multiply inside of there to get my greatest common factor, I'm going to multiply all the ones that they share. So I have to do 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So my GCF, or greatest common factor, is 24. And I'll write that up above. It'll be 24 inches. That's the side length of the largest square piece. How many pieces of this size can Shelley and Mikkel cut? Well, all we have to do is figure out what's left over for this, and then we can go through and multiply it. So before we were doing 24-inch pieces, and up above here we broke it by 7 because that was our, or 3, sorry, because that was our greatest common factor. So how many 3-inch pieces could I take out of 21? It was 7. How many 3-inch pieces could I take out of 36? It was 12. So down here, we're doing it with 24. How many 24-inch pieces can I take out of 48? Well, what's left over? It's right there. 2. How many 24-inch pieces can I take out of 68? It's right there. 7. Now I just need to multiply. So that's how many pieces that size they can cut. And that's 14 pieces. And the way we got that was 2 times 7. So I hope this helps. Thanks for watching, and good luck on the rest of your problem set.